Okay. Hi. Hi, everyone. Thanks for coming for PG Day 2. We are having another talk from Mr. Michael. Some of you might have heard him this morning for the first talk. He's now doing the second last talk of the day. Right. So the topic is injection points of FOSSASIA PG Day 2025. Right. So yeah, we'll just pass the time to him. Yeah, thank you.
Yes, thank you. How long do I have for this talk? How many minutes?
40-minute talk, 40.
40 minutes?
Yes.
Okay.
Okay, thanks.
So before doing the talk and before everybody goes back into their laptops, not being interested by what I'm going to talk about, I have a question for you. Who in this room does hacking on PostgreSQL? And by that, I know you do. I know you do. By that, I mean hacking on PostgreSQL core code, hacking on PostgreSQL extensions that touch the server side, the backend. Who does? And you don't need to raise your hand. I know. Okay, so you have a few of them. This talk is about a facility I have designed and implemented in PostgreSQL because basically doing advanced testing in PostgreSQL sucks. And I wanted something to give me ways to automate and make efficient tests for complicated scenarios, basically. So I'm going into the details of that. I'm trying to advocate that to hackers, people who do PostgreSQL hacking, be it involving the PostgreSQL core code, extension code as well. And I hope that the insights I'm giving in this talk will help you when you do any kind of PostgreSQL hacking. This really concerns the back-end side, not the clients. So this slide is also from this morning. I think everybody here has heard about that. I'm French, based in Tokyo, working at AWS since 2022. And this feature has been developed in PostgreSQL for the version 17. The first commit was, I think, 1 year ago. I am a PostgreSQL contributor since 2009. I am involved in patch reviews, authorship. This one is something I've written and committed myself. Some other people who are smarter than me have redesigned it in a few ways to adapt it to what they required, but I'm going to talk a little bit about that. And I do act as a committer of the project since 2018. I may be in some, I don't know, of the top 10 contributors of the project for the whole project history. It comes in a number of commits done in PostgreSQL. Anyway, so today what I'm going to talk about the injection points is the concept, why I've been doing that, the core facilities that we have, and some simple examples that you may be able to reuse if you do hacking on PostgreSQL, be it to fix a bug, implement a new feature, or even do your own extension code, because it's also about that. So simply put it, the concept. First, why would I actually do that? The issue is that PostgreSQL, based on its infrastructure and design, makes testing really hard in some cases. By that, is that it uses a multi-process infrastructure. It's not threading for the moment. It's multi-process infrastructure, so trying to take synchronous actions across multiple processes can be very, very tricky depending on the problem you are trying to solve and what you are trying to test. In the past, one of the patterns I've seen a lot in the PostgreSQL mailing list is if you want to reproduce this problem, you need to assign a debugger to this given process, go into this given point, stop it, take a breakpoint, and then rush this second session that does the same thing, takes a second point, and I've seen that up to like 3 GDB sessions that you need to take in parallel. But it doesn't scale. You need to test that automatically. And you can do that in some way in PostgreSQL, but you cannot really take precise synchronous actions that allow you to reproduce race conditions. There are tricks you can do when it comes to that people I've seen using. For example, one trick I've seen is to take a lock on PG database. If you do that, you can actually block connections. And I've been able to use that to reproduce for a test case involving auto vacuum that decided to not remove statistics, causing stale statistics to be created in a bug I had like 1 year, something ago. And it's also one of the reasons I saw that say, oh, it's a waste of time, it's hard to use, and it has a lot of limitations. You can also use hooks. We do that in some parts of the tree, for example, SRC test modules, to reproduce tests for APIs internally. But it's limited by the code path you use and the stack, the arguments that you actually pass to the hook. For example, you have the utility hook that has an access to some states, but you don't have an access of everything. You want to be able to manipulate the stack, you want to do some stuff, but hooks are very limited. Extensions are good, sometimes, usually never when it comes to advanced testing because they depend on the code path, you can actually plug in things. If you have a custom type, a custom access method, many things you can do. But when it comes to PostgreSQL itself, internally, they are not actually that good for that. So listing a few requirements, if you do software engineering, I think a lot of those apply to any products you are going to design. So this is kind of common, I think, but it's kind of a simple list of things. I wanted to make something, I'm a developer, for developers. And what I wanted to do in 2 lines simply is be able to run custom code at custom precise location in a given file at a given line. It has a few requirements based on my experience as a maintainer of PostgreSQL. I wanted the thing to be flexible. By that, if I do a critical bug fix, be it a security bug fix, because I'm also part of the security team, and sometimes we're under time pressure, not only in core, but if you do even proprietary stuff, it happens. I want something that's able to work in the core code, in extensions, and also I want something that can be backported into stable branches without having to care about any kind of compatibility. Because the important part is really to be able to focus on the bug and fixing the issue, but you also want to be able to automate the fix to make sure that your regression does not show up once again. And some cases are very, very tricky depending on what you do in PostgreSQL. I wanted that to be customizable and extensible, such as people can build on top of what I did. So what I've done is really a minimal design, and then some people have come in and say, I want to do that. I say, okay, if you want to do it, just feel free to do it. I'm not going to do it, but the facility has been designed such as it's possible for people to build on top of that. Another thing is maintenance. Maintenance should be minimal. The basic APIs we have, I think, are good enough for the time being, and people seem to be happy with them. Still, we can build on top of that. So in terms of test designs, the patterns I've seen, which are the most famous ones in PostgreSQL, if you want to trigger specific behaviors when you do tests, is to be able to force error states, for example. I want to have, in this given line, an error happening. If I do that, PostgreSQL does a long jump back into the beginning of the startup state, reinitializes itself, and it's very easy to break static states in backends, for example. I want to be able to do fatal panics. Panic is the state where you force recovery to happen. A lot of cases I've dealt with in the past was, for example, hard coding a loop in the backend of PostgreSQL, having with a slip, and using a file that's in TMP to say if I want to continue the loop or not. I don't do that anymore, but I'm going to show you that a little bit later. Another thing I wanted to do is a dynamic stack manipulation, such as it's possible to change, depending on the code path you are using, change one single variable, and you can, for example, do a lot of fancy things like emulate corruptions, change a single flag to trigger states that wouldn't normally be reached. You can improve the reliability of the system, emulate, for example, partial writes, do things like that. So I wanted to be able to do that. We were not able to do so in PostgreSQL. So it comes to that also, you have the cross-process interactions, which are basically 2 things. I want to be able to wait in a process, wake it up, and I want to be able to check if it's actually waiting. So you have a monitoring part and also wait and wake. These are really the main requirements I have. And of course, one thing also that shows up is I want to be able to print some information such as have I reached a given state, and I want to be able to check it if I look, for example, at the server logs. So what we have is really able to do all that. There has been a lot of proposals in the past proposed to the community. So I'm going to ask you guys a question. Do you know about a project called Green Plum? So Green Plum has a concept called, you worked for Pivotal or VMware? I mean, they didn't call it injection points, but the point is that they actually did propose an equivalent of that. But you look at the proposal and the invasiveness of the change was by design not acceptable because they had to plug in a lot of states in the postmaster. There has been a lot of proposals for that. Another one from Alexander Kokov, who is now working for Supabase, which is this thread beta infra for concurrency. I found that also very complicated, and I'm not sure I've been able to understand it, and even now I'm not completely sure I would be able to understand it. There has been another thing called probe point, which is a concept that has been introduced by Second Quadrant, that has been a company that's now part of EDB. You can look at this thread, which is something that Craig Gringer, who is based in Australia, has introduced. So Green Plum. But the thing is that I've also seen forks of PostgreSQL do that a lot. Like, so I'm working for Amazon, but basically, even for BaaS companies, people want to be able to have a strict control of what happens in tests because they want, depending on what they fix, to have ways to reproduce and not have regressions, such as customers never come back if they have an issue. So they want, for example, to have a hard-coded slip. You want to force a state. You really want to precisely force some states in your database to happen. And what I've seen is that everybody does the same thing. Everybody duplicates the same facilities, and everybody uses a different language. If you have a set of n products, you can mostly make sure that there are at least n+1 different languages being used to implement the same thing. Everybody does it. So what I've done is to say, okay, we don't have that in PostgreSQL. Let's just design something from scratch and make something that people can use. So on the code base, you can, it's disabled by default. It's for beta builds. If you use it in production, it's on you. But some people told me, I want to use that in production. It's on you. It's disabled by default, but you can use a configure switch or a meson switch that enables it. It's a C flags. The slides are online normally. You will be able to get them with all the details, and it's also on my website if you want them. But in terms of source, it's basically two files. The footprint is minimal. We have a file called injectionpoint.c, which is the backend side of that. The code is inactive if you do not use the configure switch that forces C flags. The second one is injectionpoint.h. The implementation is actually quite simple. You have an array in shared memory that stores a set of strings, names. One of them is a point name, a library name, and a function. And you have also a private area that you can use to pass down some data, but I'm giving some explanation of that a little bit. So it relies on a DLSIM, such as you can import into the backend dynamically a function from a library name. It relies, for example, on what we do for extensions, a simple code, which is called the load function name, if I remember correctly. And it's an API in PostgreSQL. The only thing is that we have a state in shared memory to be able to store that. We have for each process a cache, such as once you load the function name from the given library, you keep it stored in a static memory, and you do not need to do it once again. So if you repeatedly call the same function, you actually do not need to load it multiple times. It makes, in very hard code paths, depending on what you're actually doing, it makes the operation even more efficient. So we have some documentation that summarizes what you can actually do, what kind of APIs you can do, and we have also even examples in the tree. But going through the basics, if you define an injection point, what you need to do is define in the first line, a macro called injection point and pass a string, which is the name of it. What it is that we have a C flags, and the C flags, if enabled, would do call the function called injection point run, which is the point of running an injection point for what you did. How do you actually attach a point to the point you are going to run? We have an API called attach, so you can attach a point, a function, a callback that would be run when you run the actual point. You can also detach it. So it's really quite simple. You can attach a callback, detach a callback, and you can also run it. We have another thing called a private area, which is some data you can pass when you attach a point to be able to force the callback to take some actions. We use it in the core code. I have a few examples, but the idea is that when you attach a point, you can attach some data to it, and when you call the callback, you can run the data from this private area, giving it custom arguments to do sanity checks, to pass down conditions, for example. We use it in some way in PostgreSQL, but you can really pass down any kind of data you want and customize things. For example, Alexander Korotkov in his 2020 presentation has been using concurrency and been using JSON conditions, for example, to say, I have this PID or I have this condition I want to satisfy. We do not do that in PostgreSQL, but you could do it using those APIs. So one thing to be careful about is that if you actually load the callback, we have a function that does, so it's internal load library. It's this function that we use to load a function name from a given library. Thing is that if you call it for the first time, it needs to do a palloc. Palloc is a PostgreSQL allocation in a memory context you use at the moment you do the load. And it needs to do that to build the path to the library to be able to have the DLC able to do the load of the given function. So if you have an injection point you are running for the first time in a critical section in PostgreSQL, like if you do a start critical section, you do an injection point run, and you actually load the callback for the first time, it's going to crash, which is not something you should be able to do. So we have introduced a two-step process that allows you to load a point without running it. You start a critical section, and you can then run a point that's actually in the cache itself. So you can force and bypass the case of the palloc being run. This was not part of the initial implementation, but somebody from Neon that you may know, a Finnish guy called Heikki Nakanga, say, I want to be able to do that. Sure, feel free to implement it. And he has actually provided a patch and built on top of the initial design, and that's what we actually finished it. I think I was kind of proposing something else, but people were kind of, we don't like your solution, so the consensus was to use what we have now, and people seem to be happy about that. So, I mean, it's okay. So what you want to do is stack manipulation. So we have been discussing a few things. The initial design did not have that, but we've also run into that while I was discussing with some test cases people wanted to add. So what you can do is that you can define a macro called isInjectionPointAttached, check if the point is attached or not, and then you can do a static manipulation of the stack depending on the code path you have. We use that in the postmaster to force an error depending, and I think that we have one test that forces the backend to use the version 2 protocol, for example, to force some error states to be triggered by the backend. That's one case we've been using. And if you do that, you can force a state and then run cached injection points to check for some errors. Or, for example, you can generate an error, I think. You could also generate some notice messages. You can do a few things based on that. But the idea is kind of, you can force a state to happen in the backend. This is a graph that finishes, I think, from last October. We still have a few more injection points in the tree, but the basic facility has been committed 1 year ago, roughly in February, if I remember correctly. And this is the number of injection points we have in the tree since. We have a few more of them since, but it's just to give you an idea that we've begun doing injection points into the tree, into the core code, and we have, we had back at the time in October 16 of them. We used them for a few tests, but you can do a git grep and see where we actually define that. If you do a git grep of this macro, you would see the point names, and then you can see directly in the test where we use those point names. So the test can have many shapes, but I'm just going to cover that in the next section. So this is about the basic APIs and the basic idea. Now, how do you actually use them when you implement tests? So we have a test module called injection points. It's not in country because we wanted to be able to have the flexibility of not having to do releases of that. And we wanted to be able to make it evolve in the stable branches, but that's basically my argument for myself because I wanted the laziest solution to have to maintain that. I wanted to have a lot of flexibility here. And sometimes bug fixes are critical, but I don't want people to have to do any kind of maintenance of that. I want it to be more kind of a toolkit you can use if you want to use injection points. What we have in that is a set of SQL functions you can use to trigger the basic APIs we have on the backend side. So you can define an attach, you can detach a point, you can do a wait, define a wait point. So the callbacks we have are error, notice, and wait. And we have an SQL function that's able to do a wake up of something that's actually waiting. The point names can be defined in the core code. The actions you take for the points are defined in the module itself. So you can force, for example, we have run in the module itself, but we really use it to do some validation tests of the basic APIs. The run points are not really used in the tests because we want, for example, to run an error or to issue a notice specific to a given code path. So, for example, if you issue a SQL command, you could define an injection point that does a notice, and you wouldn't actually run it directly, but we use it for some of the regression tests in the module itself. And of course, you can load a point if you want. Load means that it would be stored in the cache of the static process, statically in the process itself, and it wouldn't be run. But it's really just a set of wrappers that work around the backend APIs. So here is a list of the APIs we have. We have a set of SQL functions able to attach, to run a cached point, to detach a point. You can load it. And it's really the basic SQL functions that we use when we implement tests. You can run them. The run is not really required for the tests themselves, but you can use it we use it for some validation. We have something called here a set local, which is something that makes use of the private area I mentioned previously. This is something that you can use for an SQL test to force an injection point to run only in the process where you actually attach it. So this means that if you execute its set local at the top of a SQL script, any point you define is going to run only in the process where the local state is set, and you can make SQL tests able to run concurrently. Because I did mention at the beginning that injection points are stored in a shared memory state, and it's shared for all the processes, but you can also define, even if you want something to only run in a specific process. And that's what, for example, the set local does. I did mention that we have a wait callback. We have a wake up function that's able to wake it up automatically depending on where you want to make one of the processes wait, which is something that you can use to emulate what we actually would do with a debugger, except that you can automate that with what we have currently in the core code. So yeah, local points. It's what I mentioned previously with the set local. It's a way to make tests able to run safely concurrently. It's mostly for SQL tests, like what we have in SRC test regress. You just need to do simply to call this function at the top of your SQL script, and any point you create will only be run in the same process as the one who did set local. So, for example, if you do Yeah, okay, so it's concurrent safe. And one property is that all points that are local to the process that define them to be so would be detached when you exit. So you can, for example, do in a SQL script an injection point set local. We have a mouse. You can attach a point foo to issue an error. Okay, the run is here. It's not a point that's part of the backend code, but just to show that. If you do that, it would run an error. And if you detach, it would just automatically remove the state from the shared memory table that we have doing that. But we have test cases that are already in the tree. You could always look at that. We have in PostgreSQL a way to do concurrent tests using the isolation tester that has been introduced originally to do advanced tests for the serializable isolation level. You can use that to have two sessions able to wait for each other. This is, for example, a simple test case where you do setup, you create the extension, tear down to drop the extension. You do a setup where you set local for one given section. You can attach a point that will wait, and you can have a second session that can do a wake up. That's a very simple test case. Somebody from Google called Noah Mish, so PostgreSQL committer, has been using this facility to do complex checks with ground tables, vacuum, and various patterns, and automate all the cases that he would be able to think about. So the point is that if you try to do that manually, it takes, I don't know, perhaps 20 to 30 minutes, and still you will need to make sure that the things are completely right. The test cases that he has implemented check a lot of crazy combinations, and I think they take 2 or 3 seconds. So, and we run them automatically, so we can actually make sure that we don't have any regressions. Once you do that, you can define permutations like other tests, and you can make steps that happen in the backend, happen in an ordered and controlled way. For example, the permutation I have done here is that I have one session that waits. It waits, it's detected by the isolation tester using pgstat activity. It sees that the event is being waiting, and you can wake it up automatically in a second session. You can also force a detach, and there is also a trick here called no-op, which is something related to the isolation tester to force a step ordering, but that's a trick that I've been using a little bit. But the idea is that you can really use, using those steps, you can force the backend to wait at a given step, and you can make it where, I mean, you can wake it up if you want. You can define as many points as you want. I think the most complicated test case we have now is something that uses up to 3 wait points, if I remember correctly. So you issue 1 or 2 waits. It depends on the order of the actions you actually want to do. You could wait at some point, do some actions, wake it up, make a second wait in the same process. You can really do a lot of things. And the footprint in the backend is only to have the simple addition of these macro injection points that you can also do a git grep on to see which area of the code we're actually waiting on. That's really, for isolation tests, it's really mostly only a wait and wake up, because you don't really care about forcing a state. Even if you could force an error or do some concurrent, I don't know, stuff with it, you could also do that. I don't think we do that yet, actually, but I mean, you could do it. We also have a Perl facility called tap tests that do more advanced testing, for example, for replication setups. You can create nodes, you can do backup tests, replication tests. I know people do not like much Perl usually, but that's what we've been using in the PostgreSQL core code. People prefer, I don't know, Python, Java. The only reason why it's in Perl is because we've been using Perl for a few years. I mean, people would like to switch to something else, but the discussion does not. Point is that I don't care about that here. I just want to point out that you can also use injection points with that. We have APIs. So one thing that's important for that is that usually if you want to do a wait and wake up, you can monitor the activity of a waiting injection point in the pgstat activity using a wait event. So we have a category called injection points. And if you register a point name with the name, I don't know, foobar, it would show up in pgstat activity as foobar. This also relies on another piece of design that I've been working on for PostgreSQL 17, which is the possibility to add wait events for extensions, custom wait events. So it's really kind of, you can add your own wait events and they would show up in pgstat activity and you can really monitor them, such as if you wait for a point, you can look at pgstat activity, and once you are sure that the point is being waited on, you can then do actions, wake it up later on. It's kind of the basic idea. It's really also wait and wake. You can do more than that, but that's really kind of the basics. So I have some examples. One is an SQL test, an isolation test, and a tab test, just to give you some idea. These are actual bugs that were in PostgreSQL, and we've been using that. I mean, they are not complicated ones. It's just to show you a little bit what we can do with that. We do much more than that, but, well, it's just an idea. So this one is about a commit that's been done, I think, at the beginning of around perhaps April, May 2024. That was a bug that we had related to reindex concurrently. I think it was in PostgreSQL 14, we have introduced a concept of what we call a safe index. A safe index is something that we would not wait on, making reindex less, having to wait for less states. So in this case, what does it mean is, for example, if your index has expressions and predicates, it could call a function that could look at data from another table, and you would need to wait for the snapshots of those other sections that could, for example, be manipulating the data of such tables. You cannot do reindexes. The bug we had was that we have a flag, simple Boolean flag, that was not being set. So we considered as safe indexes that had expressions or predicates. What this means is that if you are not careful, you would have corrupted indexes if you use reindex concurrently. So what this bug fix has been using is SQL tests with an injection point based on a notice that is run depending on if the flag is safe or not. In this case, we have index safe injection points with a reindex conc index safe or not safe. And you can check, depending on the index you are manipulating, which is, in this case, I have a simple index or index with an expression. You can check if the state is expected or not, depending on the stack of what you have been using. So that's a test that's based on a local point, and you can simply check using the SQL commands the state you actually would expect. Okay, so for isolation tests, I did mention that a little bit previously. We have some work that's been done by Noah Mish from Google. In this specific commit, where he has been doing concurrent tests with in-place updates. In this case, it was in-place updates for statistics at the end of vacuum that had issues concurrently if you try to issue commands, very specific commands like ground table or ground database. I think there were a few more patterns. The point is that he has been able to figure out crazy combinations, and he has been able to rely on that to provide automated testing to make sure that we never see these problems once again. I invite you to look the tests in place.sql. I am not diving into the details. Please do not ask me questions about that. But you can see the amount of craziness you can do with injection points and how much you can automate. One important thing is that this is an in-core test. You can do that as well in your own extensions because you have the same APIs. You can also reuse the test module, injection points. You could introduce your own module that does your more advanced conditions or something that you want to do. For example, if you have a complex product like, I don't know, I mean, there are many popular extensions like, I don't know, Citus or I don't know what. I mean, you can do a lot of things with that. You can look at this commit. Just to give you a small example, we have a simple injection point called in-place before pin, which is inside the heap in-place updates that has a wait and we basically wait in the middle of an in-place update, and we trigger the commands that were problematic concurrently. If you do that, you can check the states. You can force SQL commands and make sure that they actually have a consistent statistics. Just look at the test, and we have a single injection point that does most of the work in this case. Yes, in this case, it was updates, and we had ground revoke on tables, databases, and vacuum work happening in parallel in this case. So when it comes to TAP, one simple example, I would say rather simple example, is that we had a race condition that for a bug fix that's been, I think, fixed in 2023. It's the commit number I pointing out there, but we did not have yet an injection point to be able to check that the bug fix we have done was actually not introduced once again. So the race condition was kind of, I would say, simple. If you do restart points just after doing a promotion, there was a very small window where if you restart your server, it would panic with a famous failure saying missing checkpoint record. This is something that's been reported. We have fixed it first. And when we did that, we had a test case that was sent by the reporter, somebody from entity called Kyotaro Horiguchi in this case. And the test case was taking, I think, 2 or 3 minutes to run, if I remember correctly, because you needed to have a restart point that was long enough to allow the promotion or the restart to take time to be able to reproduce it. After using an injection point integration, it takes 5 seconds at most. And I think your machine is still pretty slow. I think it takes 2 or 3 seconds to be able to do that. What this does is using a wait point. When we do a restart point, in the startup process, you restart the node and you are able to force the state with the promotion happening in parallel. So we have a recovery test called 041 in SRC test recovery that relies on that. So that's to give you a small idea about how the test is shaped. We have a single injection point. We create an instance where we have a primary standby. We do a standby. We attach the point to make the startup process wait for it. We create a checkpoint on the primary, monitor the standby to make sure that it's waiting in the middle of the restart point. We promote it, and we then check if the state of the cluster is able to work after restarting it. The original issue is able to reproduce that we have a panic happening. The test was failing immediately. Now we're able to check that the state is correct as we want. So the regression would not be reintroduced thanks to the test. I think it's everything I have. So this injection point thing is one of the fancy toys I've been working on. We can, I think, do a bit more. I mean, there could be more improvements, but what we have, I would say, what we have currently in core is good enough that people are kind of happy with that. But what I'm trying to do is that you can use that in the PostgreSQL core code when you work on the bug fix. You can also use them in your own code, which may be proprietary code, extension, but you can, the point is that you can also use them for your own use case. I hope this has been helpful for you. If you have any questions,
yes.
feel free.
Anyone
We
has any questions?
may have some time.
Okay.
And regarding isolation test, am I correctly understood? Now, using these points, we can make additional synchronization between steps of permutation. Yes, it means that we can partly execute one step, wait another, and interesting.
Do weights. For example, you could attach 2 weights in a single SQL command, do a first weight, execute your command, you have the 2 weights, wake up the first one, let the process continue, and you could do more actions between 2 things. So you can, I think the limit of points is 128, I think, but I've never seen cases where you would actually need more than 3 or 4 points. Yeah, you can do that if you want. The point is that it's not a definition I came up with. Sorry. It's not really a definition I came up with. It's a definition that Noah Mish from Google has come up with. I want to have in injection point the equivalent of, I want to be able to automate what I would do with a debugger. And that's what we have. If you detach a point, you would still wait for it, which is what you actually do if you use GDB, for example. If you are waiting at a breakpoint, even if you remove the breakpoint, you still wait for it. So you have the same property as what you would do with a debugger, except that you can automate that and make tests out of it, yes. And you need to have one line in the backend, or I mean 2 lines if you have 2 points. But yes, it's kind of the idea. You can have injection points, for example, if you have your own table access method. You could do it as well. As long as it runs in the backend, you can really use the basic APIs for your beta builds or what you want, yes.
And sorry for asking, is it already available in master or?
It's in 17.
In 17?
Yes. So if you have, but the thing is that you need to enable the switch at the build level. So it's in the stable branch of 17. We have not really added much for master branch because people seem to be kind of happy enough with what we have. And I've just let the project go and be, because I'm not listening much from people. They seem to be kind of happy with what we have. We have a few improvements, few patches, but I mean, it's kind of working pretty well. And we have bug fixes that actually use that. So, yep.
Okay, I think we don't have more time for Q&A, but please feel free to engage Mr. Michael on the injection points. Yeah, so thank you so much. Yeah. Yeah, and also from our sponsors like AWS. Right?